So if you buy software and you have some concern around security and safety and making sure that your supply chain really is serving you and not creating software vulnerabilities and issues, stick around. We have an interesting discussion today. Really nice expert that I've asked to hop on and educate us on how you buy safe software. So if that's a topic that's interesting to you, I hope you stick around and watch. I think you'll learn something. Hi, this is Ed Amoroso. I want to welcome you to our discussion. I'm here from TAG, and I've got a colleague here, Charlie Jones from ReversingLabs. He runs product over there. He's an expert in software supply chain, and we asked him to hop on and really answer a question around how do we buy safe software? Because we all buy software. Even if you're a developer, you're doing that. So that's our topic today. We're going to get some really good advice from Charlie. He's going to tell us about the product over at ReversingLabs. So I hope you stay and listen. I think you're going to enjoy the discussion. Charlie, thanks for making time today. It's nice to see you.
Thanks for having me, Ed. Very excited to talk about one of my favorite topics.
That's good. Hey, I'm going to start with just give us the 101 on the company and the product, and then we're going to get into some tech and some detail. But give us the brief overview to get us started.
Sure. So for those that aren't familiar with kind of ReversingLabs and our offerings, the simplest way I can explain kind of the core of our product portfolio and value proposition that we bring to the market is that we help companies verify trust in digital objects. Now, what does that mean? Originally, that meant that we support our customers in analyzing single files through a number of kind of intelligence, threat hunting, malware analysis solutions that we have. But in the last few years, we've noticed that threats have really begun to start propagating through much larger digital objects, things like commercial software packages and containers. And some of the research that's kind of surfacing in this domain of security is really frightening, to be honest. We've now seen an increase in software supply chain attacks by 1,300% over the last 3 years. And ENISA, the European Security Agency, is now predicting that it will be the most prominent cyber threat by 2030. So in response to all of this, we at ReversingLabs have recently introduced a software supply chain security product called Spectra Assure to kind of help our customers combat that emerging threat.
Did you say 1,300%?
1,300%, yes, quite frightening and staggering numbers.
That's ridiculous. That's a really, really big problem. Now, when you guys are selling this, what's a typical type of customer that you're spending time with? Give us a little sense of the profile of who's buying your platform and how they're using it.
So we focus on kind of supporting two main personas when we talk about the software supply chain. First is software producers. Those are organizations who build and sell software and have an obligation to make sure it's actually secure before they ship it to their customers. And then we also have enterprise software buyers, which is really kind of the focus of today's discussion. But those are organizations who will kind of procure software to operate certain aspects of your business. And if you think about it, software is inherently intertwined into every single process that a business operates, whether it be payroll software, productivity software, messaging software, or even kind of security software. We help organizations understand, is it safe to trust those third-party software products before you buy them, before you entrust them with your sensitive data?
Yes, I mean, it's a problem we've all had. I've been at this for many decades, and it's always been this nagging question of what is what's the basis for either trusting or not trusting. What are you finding? Like, are people coming back and learning something new as they work with your platform? I would imagine that maybe even some existing vendors that they're dealing with, they have to go back and question a little bit.
Absolutely. I think success in the software supply chain is all about communication and collaboration between those two personas that we talked about. And honestly, one of the things that really makes us unique is we are able to serve both of those. And that's because we perform our analysis at a binary level rather than a source code level. So we're able to really provide insights into the security of software in the final state that it's actually shipped out to the market for use. If you think about sometimes how our solution at ReversingLabs would be operationalized in the context of a policy or a control in the business, it often gets kind of adopted as what we call a final release or a final build exam. And so that's because we capture all of these objects that may be embedded within a software package, things like installation packages, device drivers, text files, objects that get added during these final stages of development and packaging of software, and are often overlooked by some kind of security tools in the market that may sit earlier on in the software development lifecycle. And that once again positions us to support both the developer and the buyer that need to be collaborative, because we are able to support stakeholders that may not sit in the traditional development function. So they may sit outside of those. They may not have access to that software build pipeline or that source code repository, but they do have access to the final package. So that's kind of what is unique about us, is that we're providing visibility into the software supply chain and the risk it poses, but specifically to areas of business where we know there are existing blind spots.
That's cool. Most of the AppSec tools that I've ever looked at take that source code approach. You guys are looking at binaries. I mean, that is a fundamentally different and challenging approach. You guys, that requires some real cleverness to find the problems at that level. But I think it's incredibly powerful to be able to do that. Now, you told me in the past a little bit about the trust model and in this area, and it resonated with me. I wanted you to share with the listeners here a little bit about what you would view as sort of the inherent trust model that's existed in this industry as we buy software, and what you think is wrong there. I think it's a very insightful points that you make here.
Yeah, trust is a very important topic. I think traditionally organizations placed an inherent trust in software vendors, and that mainly happened for two reasons. The first was that kind of vendors of commercial software weren't previously thought to be a risky third-party type that you may engage with, and that's because you don't often share data directly with those types of vendors. You don't give them connectivity into your network. It's just this kind of commercial off-the-shelf tool that you procure, you host, and you manage yourself on your own infrastructure. We've often learned, unfortunately, obviously, that this isn't the case because of a number of these high-profile attacks that have specifically happened to software vendors between SolarWinds, CodeCov, Kaseya, 3CX. The list kind of goes on here. But it's not out of sheer negligence, I would say, that organizations don't do anything to understand that risk, because the second reason that we've placed this inherent trust in the vendors is because traditional contract structures have forced us to do that. If you think about the way that a traditional software contract is structured, they're often written as end user licensing agreements or shrink wrap agreements that kind of click here to accept the terms and download the software. And those often don't include protective clauses for a buyer, like the right to audit, like the need to kind of report and address any critical severity issues within X amount of days. So enterprise buyers didn't have many options up until now to actually verify trust, even if they recognize that it could present a material risk to their business.
You know, I want to get back to the binary thing we're talking about. As a buyer of software myself, I'm a lifetime CISO and doing software my whole career. When you buy something, it's like a black box, right? I mean, that's kind of the way you think about it. And I've always thought, man, it feels like, what kind of risk is in there that I don't know about? Because what are you going to do? This is really quite a breakthrough that you guys can go in and deal with that. Do I have that right? Is it sort of is the risk here sort of a black box kind of thing?
Absolutely. And it is a slightly horrifying concept that you don't really know what you're buying. I also like the term opaque, because essentially as buyers of software, we can't see into it. And we know that a key goal of cybersecurity or third-party risk management functions is to gain transparency into vendor risk so that you can ultimately equip the business to make some type of informed decision. Is it safe to use this product or service, or should we go elsewhere, bring our business elsewhere? And so we found that transparency into software is very difficult to achieve historically, because the product you're receiving from the vendor comes in the form of a fully compiled binary format, meaning that you have no visibility into the source code that makes up that application. And so without access to kind of these these building blocks, which make up a product, you're largely limited to kind of self-attestation from a vendor that comes in the form of maybe a security questionnaire or a statement from their leadership team. So you're reliant on them to tell you how seriously that they're taking security, which, let's be honest, doesn't instill a ton of confidence maybe in your management team because there's not a lot of substance behind claims. So we say commercial software, to your point, is a black box because there's really no way historically to understand whether it presents a risk to you as a business. And so we found that enterprises need a way to very simply answer that question. Is the software I'm buying and relying on to run maybe critical aspects of my business, is it safe to use? And so that's where we found static binary analysis to be really powerful in the hands of the consumer, where traditional security tooling maybe doesn't answer that question in a scalable way, which we aim to do.
I mean, I want to stay with that because most people listening are going to say, oh my God, I have 80 gazillion tools already. That's my technical term for the day, 80 gazillion. But they got rid of 80 gazillion tools. You know, why is it that so many of the tools that I bought, like my AppSec teams listening, have a whole bunch of tools that they've spent money on? Why have they been like this? They've been sort of inadequate in this problem. What's been the holding point? And is it just some breakthrough that you guys have come up with here? Because it is new. I mean, I stare at this area all day long, and yeah, maybe you can comment on what on that issue of, you know, I've got all these AppSec tools. How come those are inadequate at dealing with this problem?
Yeah, I mean, just because maybe the technology didn't exist to gain visibility into these commercial packages before, it doesn't mean that people weren't trying to do stuff. So they were absolutely using existing tools. Some people, like I said, relied on security questionnaires that we already mentioned. Those, as we know, kind of lack depth and really focus on really policies, procedures, controls in the vendor environment, but that overlooks the product itself. So there's limitations to that. Some people will rely on kind of endpoint detection or endpoint protection products. If you think about the antiviruses, the EDRs, the anti-malwares of the world, thinking surely if a software package is malicious, I can block it from executing on my endpoint before it's used. That often doesn't work because the modern software package tends to be very large and very complex. They'll have hundreds of thousands of components and dependencies within them. Some will have very large machine learning models under the hood of them, which is artificially bloating the package. And with these traditional endpoint security products, they weren't designed to handle really packages of this size. They were designed to deal with a very large volume of smaller files, which they deal with very well. So these large software packages that we're seeing increasing in size end up getting bypassed because tools can't deal with anything larger than a couple hundred megabytes in size. And then finally, people will also point to, hey, what about sandboxes? I want to execute this software and observe how it's behaving in my environment before I procure it. And once again, in the context of a buyer, that's actually a really good concept because you don't need access to source code to do that. But as we've seen with a lot of these sophisticated attacks like SolarWinds, malicious actors will actually build their malicious software to bypass those existing controls. So in SolarWinds case, they use something called time delay execution, which essentially means don't do anything malicious and show that you're malware until 2 weeks after it's installed on an endpoint or detonated. So the lessons we've kind of learned is that yes, software consolidation and tool consolidation is really important right now because, like you said, people have a lot of tools. But the software supply chain is a unique and incredibly complex problem that can't simply be fixed by throwing existing security tooling at a problem and hoping it's going to fix it.
You know, while you're talking, the word transparency keeps coming up in my mind here, that it's not one that we often see used in the context of cybersecurity. You always want visibility and so on. I get that. But transparency, is that the right word here? It seems like that's what you guys, in a sense, are providing, almost like the compliance frameworks and things should probably start using that designation. I don't see it often, but is that an accurate description of what you're doing? Are you providing transparency?
Yes, transparency often scares people, I think, especially when we're talking about collaboration between the publisher and the consumer, because it's like, hey, do I need to open my security posture up to everyone? It seems like sensitive, confidential information, but it's really important in the context of of software supply chain security. And the good news is we've made kind of leaps and bounds in progress in the last couple of years off the back of a lot of these attacks, not only in defining kind of how we provide visibility into software, but much more importantly, whether it poses risks or not. So the first step I'll talk through is understanding what is in the software I buy. The main mechanism for doing that, you may have heard, it's a common buzzword in the last couple of years, is the SBOM, a software bill of materials. Uh, People often compare it to a ingredients list of food products that tells you kind of what the software is made up of. So custom developed open source or commercial and third party components. But that, if we talk about transparency, that only takes you part of the way to being transparent. If we go back to the ingredient analogy, it's great to know what is in my food, but are those ingredients coming from a legitimate and trusted source? Have any of them been kind of contaminated or altered in any malicious way? Have any of them been recalled due to maybe a lack of quality? Unless you can understand those fundamental elements, it's impossible to make a decision as a consumer, do I trust this or not? And to be clear, software isn't kind of the first product or industry to go through this already. If you think back to the 80s, where you had over-the-counter drugs like Tylenol being laced with malicious components like cyanide, the results of that is drug manufacturers were getting pressure from regulatory bodies like the FDA, that they had to develop labels for the products that could be affixed to them to prove they hadn't been tampered with. And this exact same kind of phenomenon is happening now in the software industry, where people are demanding that they can prove that the software they're buying hasn't been tampered with. And so as a result, you have federal standard bodies like NIST proposing frameworks for software security labels and conformity assessments. And you have a lot more progress in the EU, where it's actually starting to be written into law through the Cyber Resilience Act. So we're kind of entering this new age of transparency for software where maybe it wasn't possible before, but now it is.
The other word that comes to mind here is continuous, and maybe the what that transparency gives you is some assurance that what you bought, is not crazy. Like that black box thing you were talking about. I love that. Like the idea of addressing black box risk should be a requirement. That I think it's a hole in our industry. But the continuous part is something that bothers me, because I don't think I would want to have a point in time here, because software is always being updated. Like, is there a continuous component, like in your product at Reversing Labs? How do I make sure that I always have some assurance that things are going to be hunky dory as long as I'm using the software?
Yeah. So the core technology of our product is what we call complex binary analysis, and it's a technology that we've kind of crafted over the last 15 years at Reversing Labs, where we can take a fully compiled software package, and regardless of size or complexity, we can deconstruct it, catalog all those digital objects and components which make up that product to tell you what's in it. But then, to my last point, is add risk context to that. So we start layering that deconstruction with threat intelligence, malware analysis to tell you whether any of that software has been compromised or tampered with in any way. Now, back to your point, software isn't like a normal maybe product or service that you may procure from a vendor. It's dynamic, it constantly changes. And those changes introduce risk. We saw that with SolarWinds, right? Where a malicious actor took advantage of the update process to actually gain a foothold into their customer networks. And so that's why within our product, we really focus on differential analysis. So not only assessing software before you release it, before you buy it and deploy it in your network, but after every change, patch, hot fix, feature release, to understand how is the maturity of that software changing over time. Is it getting worse? Is it getting better? Can you use that information to make a decision in your business? Like, let's revoke access to those older versions that may not be supported anymore or may have more vulnerabilities within them? And then more importantly, can we actually track how behaviors are changing over time? And are they starting to deviate from the intended purpose of the application where it may indicate tampering has occurred?
I mean, as new vulnerabilities pop up too, that's an issue. It may not just be the change in the software. New problems come up. So I love that. I mean, I think monitoring seems like that should be a requirement. Generally, what we're talking about here is supply chain ultimately, right? I mean, this is you always see it like if you and I were walking through a conference, we hear everybody talk about attack surface. So this this is like your software attack surface that we're talking about, and it strikes me just in listening to you this morning. This is probably the biggest part of your software attack surface, and because the binary has been something that's been largely black box risk, I guess we're all walking around with a much more exposed software attack surface than we'd ever imagined. Is that the right way? Like as we sort of close in the last few minutes here, as people are listening, is this a software attack surface kind of issue? Is that really ultimately what we're talking about?
Absolutely. We talk to organizations every day that their enterprise software estate is made up of tens of thousands of software packages that they know about, and they kind of admit that there's likely many more out there that makes up their broader attack surface. And so it kind of comes back to a fundamental need that every organization should be able to answer this basic question of, uh, is my vendor security posture getting better over time? And are they actively addressing these threats, or as you said, vulnerabilities that are being discovered in maybe older versions of software that I'm relying on to do business? Because at the end of the day, these third parties are an extension of your own business attack surface. No matter how hard you work to secure your corporate environment, you will not be successful in effectively managing risk unless you're holding your vendors accountable and you're proactively assisting them and working with them and sharing intelligence with them. This comes back to that main point of collaboration is key. So if anyone out there is considering how can I kind of uplift my attack surface management, my vendor governance strategies, and you're thinking about what are some KPIs that I can track to achieve that, software security maturity is absolutely a key factor that should be used in kind of evaluating the health of your vendor ecosystem or your general attack surface.
Charlie, this is good stuff, man. For people who want to like maybe use the product, what should they do? Is there like a POC, or is it just contact you guys and buy it? What's the process for somebody to start using this tech?
Sure, you can reach out to myself as always. I'm always available on LinkedIn and so on. I always love to talk software supply chain security,
Slide your
so I'll talk your
LinkedIn,
ear
that
off.
little the queue of all the messages. It'll say 87 when we're done.
Yeah, there you go. Yeah, be careful about that. Go to reversinglabs.com and you can learn more about Spectra Assure, our software supply chain security product, and all our other malware analysis and threat hunting products. And we can get you set up and testing software, whether it's your own software or third-party software that you purchased, or even open source software, and start giving you that visibility and transparency that we talked about today.
Man, I love this. I hope people who are watching go take action today. Go do this, man. If you're not doing it, you're leaving a big chunk of your attack surface, that software attack surface. Basically, black box risk. That doesn't sound good to me. I know that I know what I know, and I know that isn't good. So I hope people get in touch with you, Charlie. Hey, thanks for spending time today. I love I talk about this all day, but good stuff. Keep up the good work and keep us all nice and safe.
Thanks for having me, Ed. Looking forward to next time.
You bet. Thanks, Charlie. And for everyone else watching, we'll see you next time.